practice. I was looking at names and trying to quiz myself, but I still got a ways to go. So bear with me. All right, so we're talking about angles today in section 1.3. And then remember, we're going to save our constructions until Thursday. So we'll do all of our constructions on Thursday. And then in 1.4, it's really just a lot of vocabulary. So we'll look at 1.4 as well. We're going to start with stuff you should already know. What is a right angle? 90 degrees. What is an acute angle? Less than 90. What's an obtuse angle? Very good. Greater than 90 but less than 180. And what's a straight angle? Exactly 180. So in this section, there's some of that information. It's going to talk about things you already know. There's going to be the picky part of naming angles. When it's talking about naming, that's back to that real picky Miss Lashley notation of you have to name things a certain way. But classify is going to mean tell me if it is acute, right, obtuse, or straight. And those are things you already know. And then, like I said, we're going to use some of the stuff we learned last section, but apply it to angles so that we can find their measures. We'll look at protractors today. We'll save our constructions until Thursday. So lots of vocabulary, but a lot of it's pretty basic. The only reason I left this in the notes is because some of you may not know what a transit is, and so I just want to make sure that if that pops up in a word problem, you're not confused because of the vocabulary. A transit is just a tool that is used for surveying. If you've ever seen like a tripod alongside the road or out in a field, it's just a way for them to take measurements, and part of that measuring is measuring angles. And so since it's in our angles section, they may have a word problem dealing with a transit. Okay, definition for an angle. Super picky about this. It is formed by two rays, not two segments. So when you draw an angle, make sure your angle has arrows on the ends because they are rays, not segments. It's formed by two rays. Those are the sides. So you may have a question on your homework that says name the sides of your angle. If that was the case, what would you name the sides of this angle? Careful, there's two sides. Name one of the sides. RS. Remember, to name a ray, you have to start with the endpoint. So RS would be one side. What's the other side? RT. Okay, when you name a ray, you have to start with the vertex or with that endpoint. Okay. So when you have an angle, it is formed by two rays. Those are the sides, and it has a common endpoint. That common endpoint is called your vertex. So what is the vertex for my picture? R. Okay, vertex R. You don't say vertexes. The plural form is vertices, so make sure you say that correctly. And then there are three different ways you can name an angle. Some of them work all the time. Some of them only work some of the time. So I'm going to give you an example here. Okay, so sometimes you can name an angle by just using its vertex. So if I want to name this angle, I have to use an angle symbol. An angle symbol is different than a less than symbol. A less than symbol looks like this. An angle symbol is flat on the bottom. I'm not super picky about that, but I had a professor in college who was very picky about that. So I had to make sure that my angles were flat and that it didn't look like a less than symbol. So make sure that you are trying to practice that. When you name an angle, you have to have an angle symbol, and one way to name it is just by its vertex. So I could call this angle B. Okay, that only works some of the time. I'll explain to you why it doesn't work all the time in just a minute. Another way you can name it is by a number, if it's in the picture. Do not add numbers to the pictures in your textbook, okay? So if there's not a number there, don't name it by a number. But sometimes they'll put a number inside the angle, not its measurement, but just a number that you can use to identify the angle. For example, I could call this angle 1. Does that make sense? Okay, the next way works all the time, and that is you can use 3 points, a point on each ray and the vertex. So this is the third way you can name an angle. The only thing you have to be careful about is your vertex has to go in the middle. So you could name this angle A, B, C. Or you could go the other direction as long as B is in the middle. Very good. You could call it angle CBA. And that works all the time. Any questions on how to name an angle? Okay, here's an example where it doesn't work to use the vertex. How many angles are in this picture? 3. There is an angle here. I'll call it angle 1. There's an angle here. I'll call it angle 2. And then where's the third one? The big one. So if I use my vertex, and let's say that this is R, and this is S, T, and U. If I say angle R, do you have any idea which of the 3 angles I'm talking about? No. So if there's more than one angle in the picture, you cannot just use the vertex. If there's more than one angle, then you either have to use numbers if they're in the picture, or you have to use 3 letters. So I could name this angle SRT for the great big one, or I could say angle SRU, or angle angle URT for the 2 smaller ones. But I cannot call it angle R. Any questions? Yes, because again, anytime you are naming a point is named by a capital letter. So you won't use any lowercase letters for anything in here unless it's like an algebraic equation or you're just writing words. Okay? Points are named by capital letters. Okay, so again, here's an example of an angle where they've named all the different ways you could name it. Angle R, angle 1, angle SRT, angle TRS. 2 vocabulary words here, interior of your angle and exterior of your angle. When you think of interior, what do you think of? Inside. So they actually don't use it that simple. I wish they would have, but it is the set of all points between the sides. So if these are your sides, it's all the points in between there. That's the interior. When you think of exterior, what do you think of? Outside. They do use that definition. It's just the set of all points outside your angle. If it's on the angle, it's not interior or exterior. So points like S, R, and T would be on your angle. Okay? Any questions about vocabulary? And I already said all that. Okay, so let's just call this out and do it together. Somebody give me a name of one angle you see in the picture. Go, Angle QTR. All right, somebody different, name that same angle a different way. Kaylin? Angle 1. Somebody different, name that same angle a different way. Angle RTQ. Very good. So that's just one angle that's in the picture, but it's named 3 different ways. Can somebody name a different angle in the picture? Angle STR. Somebody name that a different way. Angle 2. And somebody name that another way. Kaylin? Very good. Okay, we're missing one angle in our picture. What angle are we missing? Angle 3. Well, there's not an angle 3 in the picture, right? There's no 3. So how would we name it? Angle QTS. And Faith, can you name it a different way? Very good. Angle STQ. Any questions on how to name an angle? All right, we're going to be naming angles all year long, so it's just important that you do understand how to name them. Okay, angles can be measured in 2 different ways, degrees or radians. When you get to pre-cal, you will talk a lot about measuring in radians. It's going to be very important that you're putting your degree symbol in geometry, because if you leave off the degree symbol, then that means your answer is in radians. Radians does not have a symbol. So if it's just an angle measures a number, that means it's in radians. So be really careful about your degree symbol. We are going to measure almost all the time, unless we have extra time at the end of the year, then I'll start talking about radians. If not, you'll get that in pre-cal. We will do most of our measuring in degrees. So when we talk about the measure of an angle, we're going to be talking about it in degrees. Okay? When you think about a circle, how many degrees are in a circle? 360 degrees. So when we say 1 degree, what we mean is if you took a circle and divided it into 360 little angles, one of those would be 1 degree. Does that make sense? So it is just 1/360th of a circle. Okay, these you already told me. These are vocabulary words that will be on your vocab test. Acute, right, obtuse, and straight. So just a reminder, acute's between 0 and 90. It can be 89.999. But once it reaches 90, it's a right angle. Don't forget that the little box is how you can indicate it in a picture that you have a 90-degree angle. Obtuse is going to be more than 90 but less than 180. And again, it can be 179.999, but once it hits 180, it's considered a straight angle. What is a straight angle also called? A line. And what is in a line that we've talked about in here? Two rays. And what kind of rays? Opposite rays. So when you see this picture, it can mean three different things. It could mean a line, it can mean a straight angle, or it could mean opposite rays. And it all just depends on what the context is of the question. Okay? All right. So now we're going to go to measuring angles with a protractor. First, I want you to try to answer these questions, but notice there's two parts. Find the measure of the angle. So in each one of these, you're going to find the measure. And then part two, classify. Anytime you see that word classify, that means acute, obtuse, right, or straight. So then you'll tell me what kind of angle it is. So go ahead, you and your partner. Okay, let's see how you're doing. So just a couple reminders when you're reading your angles. Make sure you're reading and marking them correctly. We're going from W to X to V. They want to know the measure of your angle. When you read a protractor, don't forget that there's two different sets of numbers on a protractor. And you're always going to start at 0 and read up to your angle. So you don't want to start here at 170 and read up, or you'll think that the answer is 150 degrees. Always start at 0 and read up. So in this case, what's the measure of the angle? 30 degrees. And that makes it what kind of angle? Acute. Now on the next one, if I were actually measuring this, I would just simply turn my protractor so that I could line up my angle, because on part B it says find the measure of ZXW. Well, that's this angle, but it's not starting at 0, right? So if we were really measuring it, we would take our protractor and turn it like this, right? And then read. But because we're using the picture on the paper, we're still going to start at 0 and read around to here. But we're not going to say that it's 130 degrees. We're going to take away the part we didn't need right here, which was how much? 30. So we have that 130 minus a 30, which is 100 degrees. And that makes it what kind of angle? Obtuse. Questions there? Everybody good with that? Okay, so let's make sure you know how to use a protractor to draw an angle. So right now we're all going to take the protractor I just passed out to you, and you are going to draw a 75-degree angle. If you don't remember how to use a protractor, look up here and watch me. So the first thing I would do is draw a ray on my paper. Use your straight edge and draw a ray. Anywhere you want. That's the first part of your angle. So find some room, either maybe on the back of your notes or somewhere where you feel like you have room. Draw yourself a ray. And then remember to be careful when you grab your protractor. The circle in the middle of the bottom of your protractor needs to be lined up with your vertex. So put that circle on that vertex. And then make sure you line up your protractor where 0 is right on your ray. So I have my circle lined up with the center of my protractor, and I have 0 lined up with my ray. And then make sure you read from 0 around to 75. Then make a little mark at 75 on your paper. So everybody with me? 0 around to 75, make a mark. Then you can take your protractor and turn it so that you have your vertex and the mark you made lined up, and you can make a nice straight ray going from your vertex through your mark. And if you did it correctly, you should have a 75-degree angle drawn. Did I lose anybody? If you have any questions, let me know. I'll come to you and help you. Some of these things we learn to do in younger grades, and then we don't do it anymore, and so we forget. Like, how do I use that? What do I do? Any questions on the protractor? Okay, just be very careful when you're reading that you're always reading from 0. So if you're going from the left to the right reading, make sure you start at 0 and read the top numbers, okay? That's usually where I see students make mistakes. Okay, just like last class period, we had congruent segments. In this section, we have congruent angles. What's congruent mean again? Same measure, equal measure. So congruent means that we're going to have angles that are the same measure. Don't forget about your congruent symbol that you can use. Instead of writing out the word congruent, it's an equal sign with a little squiggly above it. So anytime you need to write that something's congruent, use your congruent symbol, especially if you're trying to name shapes and say that the shapes are congruent. Also remember that picky notation I talked about. When you're naming shapes, shapes can be congruent. If you're talking about their measurements, like the distance on a line segment, distances are not congruent, distances are equal. Same idea for angles. You can have two angles that are congruent, but if you're talking about their measurements, notice the difference today, you have to put a little m in front of them. So anytime you're giving me an answer on a homework question or on a test and you want to tell me the measure of angle R is 75 degrees, you put a little m in front for measure. If you're just naming the angle, then you leave off the m and you just name it angle R. Okay? So if you're saying that two angles are equal, then you'll have measure is equal to measure because you're talking about their number values. Otherwise, if you're talking about the shapes are congruent. Everybody clear with that? Okay. And then just like on segments, we have tick marks. For angles, you have arc marks. So in order to show you that they're congruent, they'll put a little arc and a little arc, or sometimes they'll do two arcs and two arcs, or sometimes it'll be one arc and two arc, meaning that they're not congruent. Okay, so look for those arc marks in pictures because they're giving you important information. Here's the thing that always confuses students. If I have a picture of more than one angle, like this, if they're trying to tell you that the two parts are congruent, they will stagger the marks. They will not make it one solid curve. If they make it one solid curve, like this, then what they're telling you is the whole angle has a measure. Okay? So if they're saying these two are congruent, they'll stagger them. If it's one solid curve, then they're trying to give you some information about that whole angle. They won't write it in the middle because then that would land on top of the ray, so they'll shift it to one side or the other. But if you see a solid curve, that means they're talking about the whole angle. Everybody good with that? Okay. So just like last class, we had the segment addition postulate, right? And what did the segment addition postulate say, just kind of in generic words? Okay, so it's kind of like A plus B equals C, where A and B stand for what? If I have a line segment, what are those A's and B's referring to? Say it again. Okay, but so let's say that I have these points A, B, and C. Now let's try to say it differently. What is my segment addition postulate actually going to say here? Okay, and so I think you have too many pluses in what you're saying, but what you're saying is correct. It would be AB plus, like you said, BC equals AC, okay? And so in general terms, what we said without using A's and B's was just part plus part should equal the whole. Okay, so same idea for angles addition postulate. The angle addition postulate is also very important. You need to memorize the name, angle addition postulate. It says the exact same thing. Part of the angle plus part of the angle should equal the whole angle. The only thing here is they color-coded these wrong. So PQS is in blue here, but PQS is in red over here. So I'm going to fix that. Put it in blue. And then notice SQR is in red, but SQR shouldn't be in blue. It should be in red so that it matches. But part plus part equals the whole. Again, notice when they're using equals and plus signs that they're using the little m's for measure. Okay, so when you're writing correct notation. Any questions about angle addition postulate? Okay, if you already did the homework for 1-2, it's going to make this even easier. If you haven't, going through this will also help you for the 1-2 homework, okay? When we get back from lunch, we're going to look at two examples. One real simple, where you have numbers, and one when we throw in the algebra again. It's just like segments. We'll stop here. Right before we went to lunch, we were talking about angle addition postulate, part plus part equals whole. You know it's different than the segment addition postulate if the picture is about angles versus segments, but otherwise they say the same thing. So when you look at the picture, I'm going to warn you, the homework has some harder problems on it. And what makes them harder is, number one, they don't give you a picture. You have to draw the picture. So my advice when you do the homework problems is draw a picture, label your picture. If you are still stuck, pick up your phone, call or text me. But if you do text me, the first thing I'm going to ask you is, have you drawn a picture? Have you labeled it? And if you're still stuck, can you send me a picture of what you've drawn? Because then I can see if you've made a mistake, okay? So that's probably where we'll start. But I encourage you to ask if you are having any trouble. Okay, so we look at our picture. DEG is 115. Is that a part or a whole in the picture? DEG. Okay, so if you look at the picture, DEG is talking about the whole thing. So I'm going to draw a continuous arc and label that 115 degrees. That's showing me the whole angle is 115. Then they give us DEF is 48. Is that the top half or the bottom half? Top half. DEF is talking about this right here. It's 48 degrees. So the question is, what is the measure of angle FEG? So what will we need to do? Subtract. So again, it starts out real simple, like the segment addition one did last class. They give us the whole, they give us part. So to find this missing angle here, we can just take 115 and subtract 48. And what do we get? 67 degrees. Questions on how we knew to subtract? Okay, again, you can set it up, part plus part equals whole, and write that out. If you did that, you would say part, 48 degrees, plus the other part, the measure of angle FEG, is equal to the whole 115. And then when you see it written like that, you'll know, okay, now I need to subtract to find my missing part. When it's got the algebra in it, then that's when you're going to have to do that. Now, in the notes, I did not give you an example with algebra like this, because I thought you could just apply what we did with segments and apply what we just did now, but then throw in some algebraic expressions. But just to be clear, make sure, we're not going to solve this because I'm making it up and it may not work. It may give us negative numbers or something that's not true. But I'm going to throw an example up here. So let's say on the homework they give you this. What would you write down as your equation if you were trying to solve for x? Is this Caleb talking to me? Okay, is everybody with Caleb? Part plus part equals whole. And then you would just solve for x and then plug it back into whichever part they're asking you to find, if they want the whole thing or one part, or maybe it just says solve for x and you get x as your answer. Is everybody okay with that we don't actually solve one? Okay, because there is some algebra in the last example in the notes, but it deals with angle bisectors. So that's our next part of this section. So do you remember yesterday I keep saying yesterday because I have a daily class too, and so I get confused, but a couple days ago, last class, do you remember when we had a line segment? There was a point that split our line segment into two congruent parts. What was that point called? Say it again. Midpoint. So a midpoint is a point that splits a line segment into two congruent parts. An angle bisector is a ray that does the same thing to an angle. It splits an angle into two congruent parts. So an angle bisector is a ray that divides an angle into two congruent angles. So when you look at this picture, notice the directions say ray JK, which is here, bisects, which means to divide or split into two congruent parts. The big angle, LJM. So this big angle is now split by the red ray into two congruent parts. First thing I would do if this were a homework problem is mark that. You've got an arc here and an arc here. They're going to stagger them again so that you can tell it's not talking about the whole angle. Now you know these should be the same value. Does that make sense? Okay, so when you get to a problem like this one, last example in this section, right? Am I correct? Okay, so it says KM bisects angle JKL. First thing I would do is mark my picture. Draw JKL, draw ray KM, bisecting it, and then mark it with those arc marks to show that now those two arcs are congruent, or those two angles are congruent. Does that make sense? Okay. Then fill in your information. So JKM, angle JKM, so that's this angle here, is 4x plus 6. MKL, M to K to L, is 7x minus 12. And that's all they give us for this problem. So do we know part, part, and whole? No. And just like last class period, when we had segments, we had some where we didn't know part, part, and whole. But we had the word midpoint, so we knew the segments were now equal to each other. Same idea here. We have an angle bisector, so we now know the angles are equal to each other. So what can we write down? Exactly. So sometimes you'll do part plus part equals whole, but if you have that it is an angle bisector or something is being bisected, you automatically know that the parts are now equal to each other. So you can just set them equal and solve. What do you guys want to do here? Okay, subtract 4x. So I have 6 equals 3x minus 12. So what do we do next? Add our 12 to the other side. So we have 18 equals 3x. Good. Divide by 3, and what is x? 6. And then watch your directions, because sometimes all you have to do is find the variable. But in this case, it actually said find the measure of angle JKM. So you go back to JKM. That means we're looking for this angle right here. Plug in your 6 for x. And what is 4 times 6 plus 6? 30. And then just don't forget a couple picky things about notation. When you write your answer, you're going to put measure of angle JKM. So make sure you're putting those little m's. Equals, and then your 30, and don't forget your degree symbol. Any questions? Pretty easy. No confusion. Everybody feels good about it? Okay. Then we're going to switch over before we do 1-4. Somewhere on your notes, go ahead and try the two problems that are on the board. Find x in the first one and then simplify the second one. I'm going to give you a few minutes to work on that. 2, 1, 4. So if you'll flip in your notes, find the next section, 1-4 notes. This section is really just a few vocabulary words and then applying it to some problems. So we're only going to talk about some pairs of angles, starting with adjacent, and then we're going to talk about complementary versus supplementary. We're going to talk about linear pair, which is not up here, but it is in the notes, and then we're going to end with vertical angles. A lot of this you probably already learned if you remember back to your 7th grade math class, because they mentioned those words way back then. The bad thing is you don't use it a lot, and then all of a sudden here it is in geometry. So we're going to review it. And so here's all those words. Starting with adjacent angles. When you think of adjacent, what do you think of? Okay, kind of intersecting. And two things are adjacent. What are they? Next to each other. So adjacent angles are first of all going to be two angles. And all of these that we're talking about in section 1-4 are two angles. Pairs, okay? Adjacent angles are going to be two angles that are in the same plane. So on the same flat surface, same two-dimensional surface. They're going to be next to each other. That's why they're adjacent, but more specifically, they have to have a common vertex. So be careful. These two angles here in this picture, angles 1 and 2, are not adjacent. They are next to each other, but they do not have a common vertex, right? So this angle has a vertex down here. This angle has its vertex here. So to be adjacent, they have to have a common vertex. They also have to have a common side. So when you look at this picture, do you see that these two have a common vertex and they share this common side? Okay? And then the other thing is they can't be overlapping angles. So they cannot have any common interior points. What that means is if I were to call this big angle 3, Angles 1 and angles 3, so if I'm just looking at angle 1 and angle 3, they do have a common vertex, right? And they have a common side right here. Agreed? But if I were to pick a point out of angle 1, it is also inside angle 3. So they're overlapping angles. They are not adjacent. So adjacent angles have to be side by side, common vertex, common side, but not overlapping. Are we good with that? Okay? Because first you have to understand adjacent angles before you can understand linear pair. So again, how many is in a pair? 2. So all of this is 2 angles. If it takes more than 2, it's not a linear pair. What word is in linear? Line. So it's going to be 2 angles that form, so a pair of angles, that form a line. When you look at the picture, 3 and 4, they are adjacent and they form a line. To be a linear pair, they have to be adjacent. They have to be adjacent, and it can only be 2 angles. They have to form a line, which means that they have opposite rays going in opposite directions. Okay, here's my example. Are angles 1 and 2 a linear pair? Okay, they're not a linear pair because they're not adjacent. They do have a common vertex, but do they have a common side? No. There is a space in between here, right? That's another angle that's missing. It would take that angle too in order for, oops. See if I can get back to where I was. I'm terrible about that. Am I going ahead or didn't mean to do that? I'm in 1-3, right? Okay. I need to get through the end of this. Maybe. Now it's probably not going to let me write on the board. I hate it when I do that. Let's see. I get impatient. I touch the arrows too many times. Okay. I don't know if it'll let me write on it now, though. We'll see. Nope, that's what it does every time. I'll just write on the board. It's okay. I'd have to shut it down and do it again. But the kicker on that example is that you have this space in the middle, right? This space right here that's also needed in order to make that straight line. How many degrees is in a straight angle or a straight line? 180. So if this is 40 and this is 50, together those are not making 180 degrees. You need the measure of this angle as well. That's why a linear pair is only 2 angles that are adjacent and form a straight line. So these are not adjacent, they're not a linear pair because it takes more than 2. Is that clear? Okay, we'll see how clear it is. You have several examples in your notes. This one, and then if you'll flip your notes over real quick, there should be either 2 or 3 more. 2? Okay, do these 3 examples, this one and then the next 2 with your partner. Decide if you think they are adjacent and a linear pair, or not adjacent. Hands up, example number 1. Flip back to example number 1 here. Hands up if you think they're only adjacent. On number 1, go back to the very first one, AEB and BED. Only adjacent, hands up. Okay, hands down, adjacent and form a linear pair, hands up. Okay, hands down, not adjacent at all. Okay, so here's something that might help you if you got this one wrong, is to redraw the angles separate from the picture. So AEB is referring to this angle, so I'm going to draw AEB separate. Then BED is talking about this angle, so now I'm going to draw that angle. So look at the 2 angles. Are they touching with a common vertex and a common side? So they are adjacent. Are they forming a straight line? Yes. So therefore, it should be adjacent and form a linear pair. Does that make sense? Okay, move on to the next one. Hands up if you think the second one is only adjacent. Okay, hands down, hands up if you think they're adjacent and form a linear pair. Okay, hands down, hands up if you think they're not adjacent at all. Okay, again, it might help you. I have all three answers going on in the room. Redraw the picture. AEB is talking about this angle right here, so I'm going to redraw AEB. Then BEC is referring to this part of the angle, so now I'm going to redraw BEC. So now look at the two angles. Do they share a common vertex and a common side? So they are adjacent, but do they form a straight line? No, so it is not adjacent and form a linear pair. It is only adjacent. Questions? Okay, last one. Hands up if you think they're only adjacent. Okay, hands up if they're adjacent and form a linear pair. And hands up if they're not adjacent at all. All right, that was the whole class, so good job. That is correct, not adjacent. Any questions on that one? Everybody raised their hands, so I feel like we're good. Okay. That is adjacent and linear pair. The next two vocabulary words are complementary and supplementary. Complementary versus supplementary. Complementary and supplementary, again, are just two angles. If it takes three, they're not complementary or supplementary. So two angles, two angles. This is all about pairs. Complementary are two angles that have a sum of 90 degrees. So if you add them together, they equal 90. Supplementary has a sum of 180. So if you add them together, they equal 180. They do not have to be adjacent to be complementary or supplementary. They could be adjacent. For example, you could have two angles. When they are put together, form a right angle. Would you agree that angles 1 and 2 are now complementary? They add to be 90. Okay, but they don't have to be. If you look at this picture, which two angles are going to add to be 90? A and B. So these two would also be complementary, but they're just not adjacent. Does that make sense? Okay. Supplementary, they have to add to be 180. They could be adjacent. If they're adjacent and they add to be 180, what are they actually called? A linear pair, which is what we just talked about. Linear pairs are going to be supplementary all the time because they're going to form a straight line, but they don't have to be adjacent to be supplementary. Which two angles over here will add to be 180? A and C. So these two will be supplementary, but they're just not adjacent. If they're supplementary and they're adjacent, and it's just two angles, then we call it a linear pair. So on the homework, if they say name the most precise name, and it's a linear pair, you're not going to put adjacent or supplementary, you're going to put linear pair. Okay? Okay, so then we have the difference between complementary and the word complement, or supplementary and the word supplement. Okay, this is going to be really careful when you see those words. So here's what they mean by that. If they say, find the complement of 20 degrees, what they're asking you is, what value would you need to add to 20 to get 90? So what is the complement of 20 degrees? 70. Okay, but that's not a very good definition to use if you have a word problem. So the better definition is not what do I add to it to make it 90, but instead when you see the word complement, think 90 minus the angle. And I'm going to rewrite that instead of x as 90 minus the angle, because it depends on what you're calling your angle. It may not be that your angle's called x in the problem. So again, if I have a 50-degree angle, what is its complement? 40. 90 minus 50 is 40. Does that make sense? Okay, so the difference between complement and complementary is complement is one angle. Complementary is two angles that add to be that value. Okay, same with supplement. I'm going to change this instead of 180 minus x to 180 minus the angle, because again, it just depends on what you're calling your angle. So what is the supplement of 80 degrees? 100. What's the supplement of 50 degrees? 130. Everybody good? Okay, let's go to some problems that are pretty simple. So if you flip over, same idea. What's the complement of 59? Complement of angle F? 31. 31 degrees. Again, when you see that word complement, the best thing you can do is think 90 minus the angle. In this case, the angle is 59 degrees, so 90 minus 59 is 31, and don't forget to put your degree symbol. My daily class was kind of confused on how to note, like, I made it clear that you had to put like measure of angle, blah, 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 equals. And so they were like, what do you call it if it's the complement? Don't worry about it. You can write out the word complement, or you can just show your work and then circle 31 degrees. Okay, so don't stress about that. Look at the G one though. So first of all, do you have a numerical value for angle G? No, you have an expression. So more than likely, if your problem starts with an expression, then your answer is still going to be an expression. Does it say find x anywhere? No. So you're not trying to solve for x. You're just trying to write an expression that would represent the supplement of G. Exactly. So when you see the word supplement, you're going to think 180 minus the angle. And then you're just going to plug in whatever that angle is. So in this case, it's an entire expression. 180 minus 7x plus 10. Be careful though. If you don't put that in parentheses, you're going to forget to subtract the 7x and the 10. So make sure you put it in parentheses and distribute that negative. So you should end up with 180 minus 7x. What next? Minus 10, not plus 10. Does that make sense? So be real careful. You're subtracting the entire expression, so you have to subtract all of it. Distribute the negative. And then simplify. What can you combine there? 180 and negative 10, so what does that simplify to? 170. So you could write it as 170 minus 7x. Can you simplify that at all? How? Be careful. If you divide an expression, you have changed the value of the expression. It'd be like me saying, I'm going to give you $25, and you go, wait, let me divide by 5 first. If you divide by 5, how much money are you getting now? $5. You can only divide, multiply, take the square root, add, subtract if you have an equation, because then you're doing it to both sides and it keeps it balanced. If it's just an expression, you can't use operations to change it. You can only combine like terms. Does that make sense? Okay, so you can't go any further. This is as far as you could go. That would be the supplement. Still an expression, but G was an expression, so it's going to have to be. Questions on that one? Please stop me if you do, because it's super important you understand this before we move on to the harder one, which is next. Okay. And if I go too fast, slow me down too. Okay. So the next one is a word problem. Guaranteed you're going to see some of these on your test. Super important that you know how to work these problems. You may want to make a note to yourself. This is on the test. You will have word problems where you have to solve. I'm going to show you my algebra teacher way, and then if you're kind of confused, we can look at a geometry picture way. But since it's a word problem, I'm going to break it down kind of like you might have learned in Algebra 1. So let's read it first. An angle is 10 degrees more than 3 times the measure of its complement. Find the measure of the complement. First time I read that, I think that's kind of wordy. But if you will break it apart using your math symbols and numbers and variables and write an equation, it'll make it much easier. So start word by word. An angle. Do we know what the angle is? No. So what did you use in algebra when you didn't know a value of something? X. So an angle, we're going to call it X. Is. What do you use in math for the word is? Equals. So X equals 10 degrees more than 3 times the complement. So 10 degrees more than. What does that mean we're going to do? Oops. We're going to add 10, right? 10 degrees more than something that we're going to write down next. So we're going to put something down and then we're going to add 10 because it's 10 degrees more than that. What if it had said 10 degrees less than? We would subtract 10 from whatever else we're getting ready to write down. Okay, keep reading. It's 10 degrees more than 3 times. So that means we're going to have to multiply 3 times something, right? 3 times the measure of its complement. What did we just define the complement to be? Careful, not an angle. It is an angle, yes, I'm sorry. But what did we define the actual definition to be? Okay, 90 minus the angle. So anytime you see that word complement, you're thinking 90 minus the angle. So go back to the problem we're on. What did we call the angle to start with? X. So what am I going to put in my parentheses here for my complement? 90 minus X. Okay, so let's read it again. An angle X is equals 10 degrees more than, add 10, 3 times the measure of the complement, 90 minus the angle, or 90 minus X. Does that make sense, just dissecting it word by word? And then now we just have an algebra problem, and we're pros at that after Algebra 1, so we can do that. What do you want to do first to solve? Distribute. 3 times 90, 3 times negative X. Good, so X equals 270 minus 3X plus 10. Now what? Okay, so combine those like terms on the right. 270 and 10 becomes 280. Good, so perfect. So we have 280, and now we're going to add the 3x to the other side. And now we have 4x equals 280. And divide by 4. So what is x? 70, because 4 goes into 28 7 times, and then we still have a 0 here, so 70. Questions on finding x? Is that our answer? No, because remember, what did we let x represent? The angle, but what are we looking for? The complement, and the complement is defined to be 90 minus the angle, so our complement's going to be 90 minus 70, which is 20 degrees. Questions on the algebra way of just dissecting it word by word? Anybody want me to show them the geometry way to do it with a picture? Yes? Okay. So if you would prefer, you could think about the fact that complement, we're talking about 2 angles, right? An angle and its complement. And if we have an angle and its complement, what should they add to be when we add them together? An angle and its complement should add to be 90. So what you could do is think about it as a picture. You've got a 90-degree angle, and it's divided into 2 different angles. One angle is 10 degrees more than 3 times the complement. So you could call one of the angles x, which is going to be our complement. The other angle is 10 degrees more than 3 times that complement. 10 degrees more than 3 times that complement. Does that make sense? And then you could just use your angle addition postulate. Part plus part should equal the whole. So then you would have x plus 3x plus 10 should equal 90. Then you could solve. What's x plus 3x? 4x plus 10 equals 90. Subtract 10. Perfect. Good. 4x equals 80. Divide by 4, and x equals 20. But this time, we let x be the complement, so that means our answer is the value of the complement. Okay. So it just depends on what makes more sense to you, whether doing it like this works or dissecting it word by word works, but you just need to be able to solve those word problems. Sorry, 1 second. Mrs. Ashley? Sure, hold on 1 moment. Riley, telephone? Sorry, yes. Yes, you sure may. Anybody else need that? If they didn't write it down, go for it. Anytime you want to take a picture of the board, feel free to. It's messy. I'm a messy board person, but right all over the place. One day you're going to get to have Mrs. Seeger, and she's got beautiful handwriting. It's amazing. Like, if you go in her room, she's the last room on the right if you've never been in her room, and she's got these gigantic things in her room, like a big shoe or a big Hershey bar, or big box of Nerds. It's like she always gets all those big things that they have in cool places. But she can write fast and beautiful all at the same time. It is the most amazing thing. She is better than I am, I promise. You will appreciate her. Okay, any questions? All right, moving on. We only have one more concept to talk about and we're done, and that is talking about vertical angles. I'm going to skip this one because it's really pretty simple and I think you can figure it out on your own. So just ignore that. And let's go to vertical angles. Okay? Everybody with me on vertical angles? Okay, so vertical angles, again, you might have learned those before. The definition you need for your vocab test is they are two non-adjacent angles. Now that's different because a linear pair had to be adjacent, and then we talked about adjacent angles. But just like complementary and supplementary don't have to be adjacent, vertical angles are not adjacent. They are formed by two intersecting lines. So when two lines intersect, the ones that are vertical are the ones that are not touching each other with a common side. So in this picture, which angles would not be touching each other with a common side? 1 and 3, or 2 and 4. So basically a better way to think about it is they're the ones across from each other when two lines intersect. Are we good with that? Any questions about vertical angles? Okay, before we go further, in this chapter, this section, they require you to use a theorem on the homework that they don't teach you in this section. And so I'm going to have you add it to your notes. It is our very first theorem, and we haven't talked about what a theorem is. So somewhere on your paper, add this theorem. The difference between a theorem and a postulate. A postulate, remember, is accepted as true without proof. They are things in geometry that are kind of common sense. There's no formal mathematical proof by a mathematician, but we believe that they're true. Like, between any 2 points, there is exactly one line, right? We accept that as true. Theorems, however, are proven true. There is a formal proof for any theorem that we learn that would say this is true, okay? Now, we're not going to go through all the formal proofs of all the theorems that we learn. Some of them you're just going to believe me that there's a theorem, or you're going to go research it online if you want to and look at the theorem. Here is our very first one, and it is called the vertical angle theorem. Remember that I count off for spelling. One of the most commonly misspelled words in geometry is the word vertical. It is not C-L-E, it is C-A-L, vertical. So maybe you could tell yourself over and over again, it's vertical, vertical, vertical. So maybe you won't misspell it on the test, okay? Vertical. Vertical angle theorem, and here is what it says. Vertical angles are congruent. Vertical angles are congruent. Not formal proof here, but a simple way to prove it to you. If I tell you that angle 1 is 150 degrees, without using vertical angles, using linear pairs, would you agree that angles 1 and 4 form a linear pair? That angles 1 and 4 are side by side, adjacent, form a straight line? So if that's true, if this is 150, what does angle 4 have to be so that it forms a straight line? 30. Okay, keep going with that idea. 4 and 3, would you agree that they are a linear pair, side by side, forming a straight line? So what does angle 3 have to be? 150. And again, do it again with 2 and 3, form a straight line, linear pair. So 2 has to be 30, and now we can see that the vertical angles are congruent. Now that's not a formal proof, that's just me throwing up some numbers so you can see it, but you can see that it can be proven. Any questions? Okay, last example in your notes is just simply to name the pairs of vertical angles. So let's just do it out loud together. In this picture, there should be 2 pairs of vertical angles. Somebody name correctly one pair of those. Go for it. Angle HMJ, I heard. That's this angle here. What angle is vertical to it? Angle LMK, correct? Okay, so that's one pair. Could I have named it KML? And I could have named it JMH. It doesn't matter. Kaylin? LMH and KMJ. Very good. Again, don't forget to put those little angle symbols in front when you're naming an angle. And don't forget, if you're giving me the measure of it, to put the little m. Any questions about anything today? Yes, the little m is a lowercase little m for measure. Any other?